Good afternoon, everyone. Indeed, I will speak about OpenStreetMap and the use of OpenStreetMap to produce official governmental datasets. And this is done on behalf of also my Italian colleagues, Alessandro Sarretta and Maurizio Napolitano, that I want to thank for their contribution here. So let me start with some introduction and setting a bit the context. We know that for centuries, public sector has been the sole responsible for the collection, for the production, for the validation, for the update of geospatial information. But in a way, starting from the beginning of this century, things change, and in particular, citizen-generated data or crowdsourcing or volunteer geographic information projects in a way started challenging the role of the public sector. And the most popular example is, of course, OpenStreetMap. Since then, there has been a huge body of literature produced on the quality of OpenStreetMap and or the comparison of OpenStreetMap with authoritative data to see whether they were similar, whether they could be integrated, complemented, etc. And we have seen also different forms of actual integration happening between OpenStreetMap and authoritative data from the public sector. That means public sector bodies that have integrated OpenStreetMap in their production workflows, but also the other way around. So OpenStreetMap communities integrating public sector data through imports, but also more recently from the business sector. And I think the most popular example is the Overture Maps Foundation that at the end of last year more or less promised, well, was born with a promise to produce global, up-to-date, quality certified data sets also based on OpenStreetMap. So with this context, I will going to talk about a new data set called the National Summary Database, or DBSN, in the following, that has been recently produced by one of the Italian many cartographic bodies that we have. This is the Italian Military Geographic Institute, and this data set was released in September. Something about the data set. Yeah, so it's a vector database, and it includes geospatial information that is supposed to be used at the national level, so the scale is a medium 1 to 25,000. It derives from, mostly, as we will see later, from regional geotopographic databases at a larger scale, like 1 to 10,000, and it will be used to derive maps at smaller scales, up to 1 to 250,000. Currently, we have this new database only for 12 out of the 20 Italian regions, and you can see from the maps, well, not sure you can read, but we had two different releases of the database, one in September, and that is for the south of Italy, and one in December last year. So we have it not for the whole Italy, but for a part of it. Why is it important? Because the IGM declared that among the different data sources used to produce this new data set, they also used OpenStreetMap. And the way, in addition to the specifications, the way we can actually trace it in the database is through the attribute table. There is a specific code that points to the actual source, and this is a code for each object, for each feature in the database. So when we have the code 03, this means that object derives from OpenStreetMap, so we can actually measure that. As I said before, this also derives, and mainly derives, from geotopographic regional databases, also cadastral data, IGM data, so data that the IGM already had, and so on and so forth. There are several sources. What is interesting is that they released it under ODBL, which is the Open Database license. It's the same license of OpenStreetMap data. This is just the disclaimer that you have to accept just before downloading the data. This is important because the IGM is used, or was used, to charge users for downloading their data. This is free, and this is open access. Now, with this context, what do we want to do here? We want to understand a bit more of what is the actual role that OpenStreetMap played in the process of production of this new database. So, how much it was used, where it was used, why it was used. This through a sequence of steps. First of all, the analysis of the data models of the two data sets, then the mapping between the two to understand actually how much they can be compared. Then we try to assess exactly how OSM was used for each Italian region and province. And finally, we zoom into specific classes of objects like buildings, roads, and railways. So let me start by introducing a bit the data model of the DBSN. First of all, these specifications have a legal basis because they were included in an annex of a ministerial decree from 2011 that was signed by the Italian president of the Council of Ministers. So there's a legal base. The structure is a hierarchical one. We have, first of all, 10 layers. Layers are represented in this column. You see, for example, from the top, geodetic and photogrammetric information, roads, mobility and transport, buildings, hydrography, etc. Each layer corresponds to 2 or more themes, and then each themes correspond to 2 or more classes. So we have 10 layers, 30 themes, and 93 classes in this data model. Now, the OpenStreetMap data model should be probably well known to many of you. We have a geometric component and 3 possible primitives, nodes that are used to represent point objects, so a couple of coordinates, lat long, ways that in OpenStreetMap are used for both linear and aerial objects, and then relations which model the relationships between 2 or more nodes, ways, and or other relations. Of course, then in order to be semantically something, a geometry has tags or attributes associated to it. In OpenStreetMap, they are called tags. These are key value pairs, and we have at minimum one tag per object, but there is no limit in OpenStreetMap to the number of tags that an object can have. Now, first thing we did was a mapping between the 2 data models in order to match semantically the DBSN layers and themes to OpenStreetMap objects. So here you see just some examples for the themes corresponding to 2 layers out of the 10. So in blue you see the themes corresponding to the layer roads, mobility and transport. In red you see the themes corresponding to the layer buildings and human settlements. And of course on the right hand side all the list of OSM tags corresponding. It's important to say the 2 datasets are completely different datasets. One is a crowdsourced product, the other is a governmental product, so they were produced for different purposes by different people, so clearly there is not a perfect match. There are objects in the DBSN that have no correspondence in OSM, like for example the DTM that is modeled through TIN, triangulated irregular networks, is not available in OpenStreetMap, so which is totally okay when we compare these kind of data sets. Now, what did we do in terms of analysis? So 2, let's say, macro steps. The first one is the assessment of the OSM role in the production of the DBSN, and this happened through the download of data, the extraction of the objects that use OSM as a source, and then the enrichment of those datasets by adding all the attributes in the DBSN, and also we translated them in English, and finally we aggregate and we provide a picture for each province and each region. Second step is the comparison of the 2 datasets for specific classes. I will zoom into buildings, roads, and railways by doing some comparisons for the area of buildings and for the length of roads and railways. And then for buildings, I will show some spatial analysis that we did in order to calculate how much the 2 datasets actually intersect, overlap each other. Let me just mention, everything is written in Python, is available at this repository under, of course, an open access, an open source license to allow reproducibility. Good, so let me start from the contribution of OpenStreetMap. This is the picture that shows for each of the 12 Italian regions how much, so this is a percentage, not sure you can see very well, but this is the percentage of the total number of objects for each region, for each layer, and here for each theme that derive from OpenStreetMap. So when you see a blank cell, this means there is no object that derives from OpenStreetMap. When you see 0.0, this is actually a number higher than 0, but lower than 0.1. So this is really almost 0, but it's not. So if we look at this table, we can see that out of the 10 layers, 7 have at least one object derived from OpenStreetMap, and in particular 4, 1, 2, 3, and 4 have quite a, let's say, more significant contribution from OpenStreetMap. These are roads, mobility and transport, buildings, underground utility services, appurtenant areas. We also have very high numbers, and you probably don't see, but these are colored in red. These are above 90%. Here, I said before, the teams are 30 in total. Here we just represent those that have at least one object derived from OpenStreetMap. These are only 14. It means the other 16 have no objects derived from OpenStreetMap. So some additional messages here. Extracted from the table. So the contribution of OpenStreetMap is very variable among the 12 regions. If we look at the table that was on the left, in half of the cases the contribution is lower than 1%. So overall, let's say on average it's quite limited, but we have peaks of more than 90%. Now, well, 16 out of the 30 teams do not include any object from OpenStreetMap. Here you have the list, but also the last comment is important. The percentage always depends on the total number of objects. If I zoom back, there is a case here for the other transport and for the Molise region. Here we have 100%, but this corresponds to only one object. So one object, 100%, but this doesn't mean that, of course, OpenStreetMap is heavily used. So we need to always look at the data and not just at the numbers. If we look at the provinces, not at the region, so it's the same table as before, but we have another layer for provinces within each single region. We find out, not surprisingly, that the behavior, the pattern is the same for the provinces within each region, with some exceptions. For example, Naples here has quite a, let's say, significantly higher percentage here for the roads, and you see is the only province in Campania that has OpenStreetMap objects for other transport. So there are some cases where actually we can spot a difference within the same region. Now, zooming on buildings only, here we calculated for each province of the 12 regions where we have the data set, the ratio between the total area of buildings in OpenStreetMap and the total area of buildings in the authoritative data set, which is an indirect way to calculate the completeness of OpenStreetMap data. What can we see also visually? That in 3 regions, Sardinia, Puglia, and Toscana, we have a number that is very close or even higher than 100%. This means the total area of OpenStreetMap buildings is even higher than the total area of the authoritative datasets. But in general, the situation is very heterogeneous. Also, looking at the literature that we know very well, there might be several reasons for this heterogeneous picture. So the completeness can depend on the demographic density. We know that some areas are areas where more people live, so OpenStreetMap is more or is better mapped than some others. The attractiveness, some areas are more popular. People just go and visit those areas, so they are better mapped also for that reason. There might be also the presence or the absence of a local active OpenStreetMap community. And also imports. Of course, imports, even without a community, if building data sets are imported, then in 1 second, in a way, the completeness increases. Now, this table, in a way, complements the figure, because here we are extracting the same numbers, but at the regional level, not at the province level. These, of course, confirm that Toscana, Sardinia, and Puglia have very high numbers, even higher than 100%. We can also see that the minimum is Calabria, 35%. This means really poorly mapped in terms of buildings. If we look at the second column, this is the standard deviation of the ratio between the two areas for the provinces within each region. And here this is interesting because several values are quite small, but we have 2 very big values for Campania and Lazio. That really means there is a huge, inner variability. And if we look back at the table, the case of Campania is significant because we have only Naples. This is Naples with a very high number, a very high percentage, but all the other provinces in Campania have very low numbers. The same somehow is in Lazio, with Rome being very well mapped, but then very high variability all around. Finally, we try to do something more. We try to overlap the 2 data sets, and we look at the fraction of the area of OpenStreetMap buildings that do not intersect any building in the authoritative data set. Not surprisingly, the values are quite low. They are all lower than 4%, I think, with the exception of 3 cases, but these values are still higher than 0. So it means there is something in OpenStreetMap that is not in the authoritative database. Possible reasons, also here, we can just speculate on what the reasons could be. In favor of OpenStreetMap, the fact that the IGM, so the authoritative public sector body, is not capturing the right, all the correct objects. Or the fact that, and this is, I think, a very common message for all the public sector agencies, they really cannot keep the pace that OpenStreetMap, and as well as any crowdsourced product, evolves with. So, you know, OpenStreetMap changes continuously. So they need, and they probably are not able, or partially, they may not be able to really keep the pace of this change. Possible reasons against OpenStreetMap. There are elements that are buildings in OpenStreetMap, but that are not buildings in the DBSN, like greenhouses or roofs. Roofs are modeled as buildings in OpenStreetMap. Roofs are just buildings that only have a roof, but do not have a building structure. So these somehow are buildings, but they are not included in the DBSN. Buildings that do not exist anymore, like demolished buildings that might still be available and mapped as buildings in OpenStreetMap, but also the fact that, of course, we never expect a perfect overlap between the two data sets. So, of course, there should always be something that really, we cannot expect really a perfect overlap. So different reasons, but I think different food for thought here on what the reasons could be. Finally, a very quick slide on the roads and railways. We basically did the same thing, but this time, instead of the area, we look at the length of the roads and the length of the railways in the two data sets. We find out that in general, I think the situation is overall better than buildings. This is not surprising, especially for roads, if you look at the on the left-hand side figure, because roads are really the primary class of object that is mapped in OpenStreetMap. It's easy to map roads from satellite imagery, from GPS tracks. OpenStreetMap actually was born with roads. Anyway, we can really, by just visually looking at the figure, conclude that roads are more complete than railways, but variability is higher for railways. Also, if we look at railways, we really see some gaps in the south of Italy. That was just really a first comparison in terms of these two data sets. Let me close with some conclusions and some points for additional discussion. I think we can say that today, given the technological advancements, given the availability of crowdsourced data sets, mapping agencies actually need also crowdsourced data to close the gaps in information that they have. And we have seen that this especially happens for baseline data like roads and buildings. This is actually where OpenStreetMap is used the most. OpenStreetMap can be the solution to these data gaps, but it is not yet ready, or not yet ready everywhere, we could say. Buildings, but also roads. We cannot extrapolate general conclusions, but again, roads, railways, buildings are among the first classes of objects that are mapped in OpenStreetMap. So the situation for other classes, that could be land use, that could be POIs, would probably be only worse than this. Nevertheless, again, I would like to stress the point that this is a very interesting case in terms of the reuse of the data that the IGM does, takes data from different sources and derives a new product and licenses it as ODBL. This is interesting, I think, from the data sharing point of view. Future work. Well, we can, of course, wait that the last 8 Italian regions are released and then try to extend or replicate the analysis in order to, first of all, spot possible geographical trends, identify other OSM objects that may have even a higher potential for integration in the DBSN. We might have missed something by only looking at 12 regions. Also, clearly, we can extend the analysis on some additional layers and themes, not just buildings, roads, and railways. Something that would be interesting is to evaluate the correlation between the quality of OpenStreetMap that would need to be assessed somehow, and the use of OpenStreetMap in the DBSN. So is there any correlation between the use of OpenStreetMap, where it happens the most, and the quality that OpenStreetMap has in those provinces or regions? But also, the opposite workflow now is possible, because I said at the beginning, the DBSN is released under ODBL, and of course this makes the DBSN suitable for to be used as a source for imports into OpenStreetMap. And this is something the Italian community has started to look at, of course with interest, because it's a complete and potentially very useful source of information. This is the paper that is published in the ISPRS archives that were published last week, and where you can also find all the other papers corresponding to the talks given in this academic track. And that is it. You can also find the slides here. Thanks a lot.